Hey team, it's Mr. Z, and today we're going to go ahead and look at lesson 5, which is solving radical equations. And essentially, we're going to go ahead and figure out how to finally solve equations with square roots and cube roots. Let's go ahead and take a closer look. Okay, so find the inverse of the following equation. Okay, well, inverse means that I need to switch out the x's for the y's. So I understand that f of x represents the output, which is the y. So it becomes y equals 3x to the third minus 5. And to write it as the inverse, I switch my x for my y. So you can see I switch my variables, and now my goal is to get it back to the spot where y is by itself. So I have to use the inverse operations. Normally we go parentheses, then we do exponents, then we multiply and divide, then we add and subtract. However, with inverses, we go in the opposite order. So I'm going to add and subtract first. To get the y by itself, I'm going to add 5 to both sides. This is going to prove to be x plus 5 on the left side, and all that's going to remain is 3y to the third. I'm a step closer. I need to get y by itself. Before I do any exponent work, I have to then do multiply and divide. So what I'm going to do is I'm going to take the inverse of both sides. I'm going to divide by 3. Divide the whole left side, the whole right side. And what this is going to lead me to is on my next line, it's going to say x plus 5 divided by 3 is going to be equal to y to the third, because 3 divided by 3 is going to cancel. I've done my adding and subtracting, I multiply and divide. Now I have to do my exponent. I have to get rid of the exponent of y to the third. So I'm going to take the cube root of the right side and the left side. This is going to produce, I don't even do anything, I just rewrite it, the cube root of x plus 5 divided by 3, which is equal to y. When I write my inverse, I flip it so that y is equal to the cube root of x plus 5 over 3. And if I wanted to use this function notation, it's called f of x. So the inverse is going to be f to the negative 1 equals the cube root of x plus 5 over 3. This is the inverse. So you can see I went through the process of finding the inverse by switching x and y and using inverses to isolate the y. Number 2, simplify this expression. So the cube root of 24, x to the 7th, y to the 12th, z squared. So cube root, I think of 1 to the third, 2 to the third, 3 to the third, and 4 to the third. 1 to the third is 1, 2 to the third is 8, 24, and 64. These are the first 4 perfect cubes. I am going to rewrite my square root or my cube root of 24, and I'm going to rewrite this to be the cube root of 8, and then 8 times what? Equals 24. 3. Then I'm going to have to rewrite all of my other ones as a rational exponent. So I'm going to have multiplying x to the 7th over 3 times y to the 12th over 3 times z 2/3. I'm going to go ahead and take the cube root of 8. That's going to be 2 times the cube root of 3. Now x 7/3, when I divide it, it's going to be x to the 2 1/3 times y to the 4th. In 2/3, I can't do anything. I just rewrite it. So now I'm going to split up my x. So it's going to become 2 times the cube root of 3 times x squared times x to the 1/3 times y to the 4th times z to the 2/3. Now I'm going to go ahead and organize things without a radical and things with. So I'm going to write 2 x squared. I'm going to also write y to the 4th. And then I'm going to write my cube root of 3 times x to the 1/3 times z to the 2/3. Now I'm going to go ahead and rewrite my x to the 1/3 as a radical. So all of this on the left is going to be repeated. And I'm going to rewrite this next one as the cube root of x to the 1st times, again, the denominator is 3, so it's going to be a radical of 3 and z squared. They're all the same index, so I can combine them to be 2x squared y to the 4th times the cube root of 3x z squared. All right, number 3. X squared equals 16. How do I solve this equation? I get x by itself. What values can it be? What number squared equals 16? It is degree 2, so I should have 2 solutions. So, since it's degree 2, I'm going to go ahead and take the square root of both x squared and the square root of 16. And this is going to produce x is going to be positive or negative 4. The reason being, if I have 4 squared, that equals 4 times 4, which is 16. If I have negative 4 squared, that means negative 4 times negative 4 equals positive 16. Both of them work, hence why I have 2 solutions. For b to the x to the 5th, I'm going to go ahead and take the 5th root of each side. It's going to be x to the 5th, 1024. It's going to be x, and then because it's to the 5th root, the understanding is that essentially the number will only be positive, right? The number will only be positive, so 124, it's going to just be 32. The reason being is even roots are going to have 2 possibilities. However, with the 5th root, it's only going to be positive. So I have my solutions to both of these power functions. All right, that has been the warm-up. Hope this helped.